Hello everyone. In this video I'll be talking about 6.5. So in 6.5 we're going to be using the factoring skills we've learned in the other sections of chapter 6. And the real reason why we've been learning how to factor is so that we can ultimately solve equations. And the ones we're going to look at now are quadratic equations. So let's take a look at what's called the zero product property. This is a bit of a conceptual piece, but the reason why the factoring is necessary is held within this definition here. So the zero product property says if you have two factors and that product is equal to 0, so if you have a product of two factors set equal to 0, so for this piece, that's right here, right? If this is happening, then at least one of the factors is 0. And it's really as simple as that. But that's a conceptual idea. So let's read it again. It says, if the product of two factors is 0, then either A is 0, right? At least one of the factors is 0 means either A has to be 0 or B has to be 0. Let me show a quick table just to explain this a little bit further. So let's say we had A and B, and then over here we have A times B. And let's follow this requirement, right? A times B is 0. So let's just say I have a few different cases. But in all cases, I want A times B to be 0. So let's see what's possible. So if A is some number, I'm going to pick 13. What if A is 13? That's okay. And we can still get 0 as long as what? As long as B is 0, right? So that 13 times 0 gives us this 0. So that would be a possibility. We could have maybe -2 for B. You know, maybe I pick B this time as -2. To get a number times -2 to be 0, I need this number over here to be 0. If I just choose B to be 0, then A can be anything, right? I can put any number here, including a 0. But it would be impossible. It would be impossible to have neither of these being 0, right? So if you had a half times 2 is not 0. Right, so this doesn't work, this last row. So that's what the property is saying, is if you're getting 0 out, then 0 had to be involved in at least one spot. In this case, it's involved at both A and B. Here it's just A, right? 0 times -2 is 0. And here it's just B, 13 times 0 is 0. So that's what this property is saying. If you have two things multiplied together and it equals a 0, then at least one of those things is 0. So for our first actual problem here, we have x minus 6 times 4x plus 3, and this is all equal to 0, and we're wanting to know for what x's is this true. So just to match up with the property, this x minus 6, that is like A. And then 4x plus 3, that is playing the role of B. So we have A times B equal to 0. A times B equal to 0. So what the property says is that you can now set A equal to 0. Right? Now I'm going to do this part. So x minus 6 equals 0, or it says you can set B equal to 0. So I'll put 4x plus 3 equal to 0. So what we do is we kind of break it apart into two linear equations, and then we solve these linear equations independently. So I'll add 6, add 6. I'll subtract 3 over here. So x equals 6, it looks like, is one of our answers. And then over here, we'll have 4x equals -3. And just one more thing left to do over here is divide by that 4. So we're getting answers of x equals 6 and x equals -3/4. So that was one where the equation already had the factorization present, right? So I didn't need to factor, but just notice that this thing was factored, and that's what allowed me to solve using this zero product property. So coming up shortly, they're not already going to be in factored form, but let's try one more. So this one is already in factored form. So now this x plus 3 is playing the role of A, and this 2x minus 1 is playing the role of B, and we have our 0. If this were not equal to 0, if we had x plus 3 times 2x minus 1, if this were equal to like 6, then we can't use the property, right? It's the 0 product property. It's not the 6 product property. Okay, so we can only use this property. It's only true if your product is equal to 0. If it's equal to any number besides 0, then this property has nothing to say about it. So we're good on this one. What I now do is I can set x plus 3 equal to 0 and 2x minus 1 equal to 0, and I'll solve. So subtract 3, add 1. So x equals -3. Looks like will be one of our answers, and then we'll have this 2x equals 1, and then divide by 2. So we're also getting an x equals a positive 1/2. Keep in mind you can always check these, right? You can plug these back in. So I'll go ahead and do that. Let's just check one of them, but they both should work, but I'll just check the -3. So is it true that -3 plus 3 times 2 times -3 minus 1 equals 0? So -3 plus 3, 0. 2 times -3, -6, minus 1, -7. So we have 0 times -7, and yeah, that is equal to 0, right? We just need a 0 in at least one of those spots. Okay, so part 2 is our first glimpse at one that isn't already factored. So what I'm going to do is factor it first. It's already set equal to 0. So if I factor the left-hand side, then I'll be able to use the 0 product property. So the way I was emphasizing was this A times C approach. So A times C, 1 times 5 is 5. And then I've been saying, let's go ahead and find factors of 5 that add up to, in this case, -6. So we could use -1 and -5. So then what we do is we bring those numbers in as coefficients. So the same factoring process that we were doing, not attached to solving, we're now doing within a solving context, but it's the same factoring process. So x squared minus x minus 5x plus 5 equals 0. So I brought these numbers in, right? Here's my -1 essentially, as coefficients on x. Right, there's that -1, and here's that -5. Now what we do is we factor by grouping. So I'm going to factor those groups. The commonality here is an x, so I'll factor out x, leaving behind an x minus 1. I have a leading negative here, so something I've been recommending is to factor out that leading negative. So I'm going to factor out a -5, and that'll leave behind an x minus 1. This is all still equal to 0. Right, x minus 1, because -5 times x is -5x, and -5 times -1 is that +5. So now we factor out this commonality. So they both share that x minus 1, so I'll factor it out. And x minus 5 is left behind. This is equal to 0. And now it looks like the ones we've done already, right, where it's in factored form. So now we use the zero product property. We set x minus 1 equal to 0, and we also set x minus 5 equal to 0 because we have our 0 over here. That's the proper move. So it looks like we're getting x equals 1 and x equals 5. Okay, I'll leave it up to you to check, but those should check. You should, if you plug in a 5, you should see that, yeah, indeed you get a 0 on the left. Okay. Next one. So yeah, something now that's been there from the start has been our 0, right? So you want a 0 somewhere on one side or the other. It actually doesn't matter what side you choose for 0. But I don't have my 0 yet. I have a 4x squared, I have a 2x. I want a 0, let's just say on the right. It really doesn't matter which side though. So I'm going to subtract over the 2x. So that'll be 4x squared minus 2x now equals 0. And now factor out the GCF. Remember, that's kind of the first step, even though I didn't talk about it here. We're really often looking throughout the terms as the first step and saying, is there anything in common that I can factor out front? So with this one, that's actually going to produce something, right? We have a 4x squared, a -2x, so I can factor out a 2x, leaving behind a 2x minus 1. It looks a little different, but this is now playing the role of A, this is playing the role of B, and here's my 0. So I have A times B equals 0. So I can set 2x equal to 0 or 2x minus 1 equal to 0 and solve those. So divide by 2, add 1. So I get x equals 0. Right? 0 divided by 2 is still just 0. And then on this one, we have 2x equals 1 and divide by 2. So we're getting x equals 0, and then from this one, we're getting x equals a half. Okay. So part 4, this is on page 70. So again, like I was just saying, we need our 0. So I'm just going to choose to bring everything to the left, but it actually doesn't matter what side you choose. So I'm going to bring this 10a over, and then I'll actually add this 25 maybe at the same time. Kind of messy work there, but I'll say a squared minus 10a plus 25, right? That now equals 0. And factor, right? So if you want to use the a times c approach, you're welcome to. If you have a different approach that works, then please use that, right? A times c, not this a, but really I'm thinking of like the coefficient. So 1 times 25 gives us this 25, and then we're trying to add up to negative 10 in this case. So negative 5 and negative 5. So I'll split up that middle term. We'll have a squared minus 5a plus 25 equals 0. Right, so again, those, after you determine the numbers that solve this puzzle, then those come in as the coefficients on your middle term. Then factor by grouping. So I'll factor out an a minus 5 left behind, and a negative 5 there, a minus 5 left behind again, right? Negative 5 times the a gives you the negative 5a, and then negative 5 times negative 5 gives you the positive 25. Then we have this commonality that appears. Factor it out, so a minus 5, leaving behind actually a minus 5. And you might be thinking, oh, let's set both of them equal to 0. And really, yeah, you are. But really just setting one equal to 0 is going to be sufficient. So a minus 5, since they're both the same, we're just going to get a 5, kind of twice. But there is just one solution here. I'm going to skip actually to part 6. Okay, so as I was saying earlier, something I'm not going to do is to set each of these terms equal to 28. That is not correct. So what I'm first going to do actually is FOIL this left-hand side, and I'll show you what I mean by FOIL. So I'm going to basically carry out the multiplication by doing the first. What I mean by first is this first combination. So that first combination is going to be x squared. Then I go to the outside. So what I mean by outside is this combination. So that'll be negative 2x. And then we go to the inside. What I mean by inside is this inner combination. And then last. So this is what I mean by FOIL, F-O-I-L. It's just a way of remembering to carry out all those combinations. So now the last is this last pairing. So plus 10 equals 28. So this 28, I actually want a 0 there. So I'm going to subtract that over. And I'll combine that with the 10. So we'll have x squared minus 7x and then minus 18 equals 0. So this equation is actually equivalent to this one, except it has a 0 on the right, which we want because we're going to want to apply the zero product property in a second. So a times c would be negative 18. Factor negative 18, looking for factors that add up to negative 7. Right? So we could do negative 9 and 2. Right? That's a good choice because negative 9 times 2 is negative 18. And negative 9 plus 2 is negative 7. So now we rewrite the middle term using these numbers as coefficients. So I'll have x squared minus 9x plus 2x minus 18 equals 0. All right, so I've written those numbers in here. Then go ahead and factor by grouping. So I'm going to factor this group and this group. So x, leaving behind an x minus 9, factor out a 2, leaving behind an x minus 9, and this is all still equal to 0. Then this x minus 9 appears, factor it out. So I'll have x minus 9 times what's left behind this x plus 2. Now this all equals 0. And now finally we can use the zero product property. We have a product, right, where this is acting like A, and this is acting like B. And this is all equal to 0 now, not 28, right? So now I'll set x minus 9 equal to 0 or x plus 2 equal to 0. So add 9, subtract 2. So x equals 9, x equals negative 2. Maybe let's take a moment to check that. So I'll just do a check up here on, I'll just check with 9, but they both need to work. Mind you, I'm just going to save a little time, but I'm just going to check with 9. So is it true that 9 minus 5 times 9 minus 2 is equal to 28? All right, so I'm just checking with 9. You would need to go back and check with negative 2 though, right? So 9 minus 5, 4. 9 minus 2, 7. 4 times 7 is 28. Okay, I'll do one of these applications and then that'll be the video. Of course, I'll attach all the solutions next to the video. So an application. So it says a pumpkin is launched from a very powerful cannon. So I don't know if you guys have seen that. These ridiculous cannons they build, and then they put a pumpkin in there and they can launch these things like a mile. Anyways, this is what I'm kind of alluding to here. A pumpkin is launched from a very powerful cannon. The pumpkin's path is modeled by the quadratic function f equals negative x squared plus x, where f represents the pumpkin's height in miles and x represents the pumpkin's horizontal location in miles. How far was this pumpkin launched? What maximum height did it reach during its journey? Okay. So yeah, what is this function doing for us? Basically, if we tell it a horizontal location, then it'll tell us how high above the ground the pumpkin is at that horizontal location. Or if we tell the function how high the pumpkin is, we can figure out where horizontally the pumpkin was at that time. And that's actually what we want to do here. So for this first part, how far was the pumpkin launched? A way of figuring that out is saying, well, if it got launched from here and then went way over here, however long this distance is, right? That would be like the answer to that question. If the pumpkin got launched from here, and I'm thinking of this as like x, and this is f of x, the height, whatever this distance is, right? That'll be how far the pumpkin got launched. So how do we find these? These are points when f of x is equal to 0. And that's the important conceptual piece. So this is a spot where the height is 0, and this is a spot where the height is 0. So if you can find the points at which the height was 0, you're really finding the launch site and the landing zone. So that's algebraically what I'm going to do. I'm going to plug in 0 into the height, because that will correspond to the locations at which the pumpkin was on the ground, right? At the beginning of the launch and at the end of its journey. So 0 equals negative x squared plus x. So basically, where, for what x, is this thing at a height 0, right? It might be a couple different x's. How have we been solving these? Well, we first want to think about any common factors. So if I look over here, we do have something in common. So I'm going to factor out actually a negative x, and that will leave behind an x minus 1. Right, so negative x, I'm factoring out that leading negative, but also they share an x, so factor it out. So I have this negative x. If that negative x comes out, then we have a negative x times x gives us the negative x squared. Negative x times negative 1 gives us positive x. That is a good factorization. Then this is acting like our a. This is acting like our b. And we have our 0 from the 0 product property. So I can set each of these factors equal to 0. And solve. So I'll add 1, and I'll actually divide by negative 1 here. So I get 0 equals x, or 1 equals x. So I'm getting a picture to appear. It really more was like that it got launched from 0 and then it landed at 1. Right? I'm saying that because here's when it was on the ground at x equals 0. That's right there. And then here's the next time it was on the ground at x equals 1, and that's 1 mile. So if it went from 0 to 1, that means it went 1 mile. Okay. In horizontal distance. Now we have this follow-up question. What maximum height did it reach during its journey? So think through this one. We kind of have a sketch of the path. So where does it appear, where would the maximum height occur on this arc? It would occur right in the middle. So this peak is going to be defined by, in this case, x equals 1/2. Right, here's 0, here's 1. So right in the middle of 0 and 1 is 1/2. So at x equals 1/2, we'll actually get the maximum height. So what I'll do is I'll use this function. So I'll say this is kind of for part 2 right here. So f of 1/2 equals negative 1/2 squared. I'm plugging in a half into the function, plus 1/2. whatever this number is the maximum height. So negative. So I'm just typing this in. And then plus 1/2. So the maximum height was 1/4 of a mile. So kind of around 1,000 feet, but I'm going to put 1/4 of a mile. So that was the maximum height. So we would see 1/4 over here. Okay, so that's, that was a case where actually we needed to factor to figure out something real about the world. All right, talk to you all next time. Bye-bye.